Paula. I'm here because I am benthic foraminifera specialist. So we are here to look for the benthics and see what they tell us about the paleo environment, the environment of the deep sea when they were living there.
My name is HITOMI UCHIMURA, and I'm studying benthic foraminifera. I want to know relation to Costa Rican tectonic.
My name is BURKETT, and I am a micropaleontologist specializing in benthic foraminifera. Forams are single-celled organisms that have a test or shell-like structure that are prevalent in the fossil record from about 540 million years ago to now.
I'm Maria. I am doing my PhD in Switzerland in the University of Lausanne. I'm specialized in Radiolarians. What are Radiolarians? Okay. This is a Radiolarian, you see? This is an Spumilarian. This is the more typical, like a sphere. It has these spines normally. A Radiolarian is a marine plankton, and the skeleton is made of silica. There is lots of different kinds. We have 500 different species of Radiolarians.
My name is BAXTER. I'm a micropaleontologist on board. I just deal mainly in Radiolarians and nanofossils. Both can tell you subtly different things about the oceans that they existed in and the age that they were alive. So just using any type of microfossil in order to help with bigger processes like tectonics.
Micropaleontology is fascinating in and of itself, but on this ship we're using it primarily for biostratigraphy. Biostratigraphy is using microfossils to get an idea of the age of the material that we're looking at.
It's nice to have a continuous sequence that you can actually see the different assemblages or groups of fossils as we drill down, and we can see the change. So we see the introduction of a new species of fossil, or else we see the demise and extinction of a species of fossil. And this can tell us when the ages change.
Between biostratigraphy, the biostratigraphers and the paleomagnetism, they can come together and you build the final, let's say, final age framework for the ship.
How we confirm, especially with the comparison, could be with paleomagnetists, with PMAG.
My name is Xixi Zhao. I'm a shipboard paleomagnetic. Paleomagnetism is a study of Earth's magnetic field in the past, the ancient Earth's magnetic field. In Chinese, we call 古地磁学, which is more precisely reflect the translation, because in Chinese, 古 means paleo, 地磁 means geomagnetism, 学 means study. If English paleomagnetism is just paleo and the magnetism. The Earth has a magnetic field. We think Earth's magnetic field is generated from outer core. Our Earth has a layered structure. We have inner core, outer core, mantle, crust. Because the inner core is a solid iron, that's what we think. But the outer core is fluids. It's metallic fluids, iron, nickel, all these fluids. So when these fluids, with Earth's rotation, when these electronic fluids are rotating, it will produce a field. Earth not only has a magnetic field, this field is dynamic because it changes positions, so-called geomagnetic reversal. They found in one reversal, which are around 70 million years ago, somewhere in Miocene, the field changed itself so fast, about 6 degrees a day. So if you imagine North Pole and the South Pole, the angular distance is 180 degrees apart. So if it was 6 degrees a day, something like a month, you will swing the whole thing. But like today, Earth's field has not reversed itself for the last 780,000 years. And if you look at the records back to 10 million years ago, you just count how many reversals, you average them out. It's about 4 or 5 reversals per million year. So we are, almost 1 million year, 0.78, no reversal. It's kind of strange. Well, we study these ancient records of geomagnetic field by measuring the remnant magnetization, which is carried by the magnetic minerals, for example, magnetite or hematite or those things. They record Earth's magnetic field when they were formed. For sediments, like we're doing here now, imagine little tiny magnetic mineral, like little grain and needle. When they deposit in the seafloor with other sediments, they will record the Earth's field at that time.
I have to run.